everyone. This week we are going to be talking about sequences, series, and patterns, starting with arithmetic sequences. So, for our first problem, a child's mother gives her 10 cents one day. Every day thereafter, her mother gives her 3 more cents than the previous day. After 20 days, how much does she have? So we can represent this problem using an arithmetic sequence. The sequence would be first day, 10 cents. Second day, 13 cents. Third day, 16 cents. Fourth day, 19 cents. 22 cents, and so on. So this here is our arithmetic sequence. But that's different from an arithmetic series. In an arithmetic series, we sum all this up, 10 plus 13 plus 16 plus 19 plus 22, and so on. And what we want to know for this problem is the arithmetic series for this arithmetic sequence. And we're limiting it to 20 days too, of course. So how do we solve this problem? Well, the second problem will teach you a neat formula for finding arithmetic series, but right now we're just going to logic it. So, and hopefully this will make you more comfortable with this whole concept. So what you notice is that we're increasing from here, we're increasing by 3 each time. So you can sort of create like a pyramid that will give you the sum of this arithmetic sequence. So here, if I draw something like this, and okay, bear with me here. If I draw something like this, I say this is split into 20 days. 20 days. So this is how long this thing is. And so she's always going to receive 10 cents. But every day after, she receives 3 more cents than the previous day. So here, we have a small bump of 3 cents. And then here, we have another small bump of 3 cents. And each day she's getting 3 more cents than the previous day. Another small bump of 3 cents. Another small bump of 3 cents, and so forth, until we reach her 20th day. And we can actually figure out how much money she receives for the 20th day. Okay, for example, on the first day, here's day 1, right here, she receives 10 cents. On the second day, she receives 10 cents plus 3. So first day, 10 cents. Second day, 10 cents plus 3. Third day, right over here, she receives 10 cents plus 2 times 3. So we can extrapolate this all the way to the 20th day. In the 20th day, she receives 10 cents plus 19 times 3. Because there are 19 jumps of 3 to get from 10 to however many cents she's receiving on the 20th day. So this is the general concept, and by understanding this, we will be a lot more prepared for our second problem, where we're going to prove the formula for finding arithmetic series from an arithmetic sequence. And once we have proved that formula, we can use it and apply it to the first problem right here. So the first problem is a bit of an intro, I suppose. Okay, we're gonna briefly skip over the first problem, move on to the second problem before coming back to the first. Prove that a plus d plus a plus 2d plus a lot of numbers in between plus a plus n minus 1d is equal to, okay, you know what, it's probably better if I write this out rather than saying it out loud. Oh, here's red, very spooky. So, a plus, oh, this ink is good. A plus 2d plus a plus n minus 1d. That is supposed to be equal to n over 2 times 2a plus n minus 1d. This is a lot of variables, and I know it looks a little bit scary, especially because I wrote it in red, and red is such a violent color. Okay, right, this is an arithmetic series, and all of these variables represent certain things. A is the first term. D is the difference. And N is the total number of terms. So if we look back to our first problem, we have 10, 13, 16, 19, 22, and so on. If we apply to this formula here, 10, A is equal to 10 because 10 is the first term. And then the next term, we're increasing by 3. So the next term is 10 plus the difference, 3. 10 plus 3 is equal to 13. So that's the second term. And then for 16, we have 10 plus 2 times 3, or 10 plus 6, 16, and so on. And you notice for our last term, our 20th term in our problem, we have 10 plus 3 times 19. And so this is what this represents, 10 plus n minus 1. Well, n is the total number of terms, 20. 20 minus 1 is 19. A plus 19 times 10, A, okay, I'm getting a bit confused here. 10 plus 19 times 3. Exactly what this states here. Try to internalize it, make sure you understand why the last term is n minus 1. Oh, I should add a parentheses. Try to understand this part first, and then I'll show you how we get from this all the way to this here. When we have this here, we can actually solve our first problem without making it too complicated. Alright, so to prove this, I have to kind of erase all of this. Try to memorize this part, make sure you understand what all of these variables represent. I'm going to get rid of this part too. So right here is the arithmetic series. And this could be any arithmetic series. This right now, oh, I should use another color too. A is the first term, number 1. This is the nth term. And we can also rewrite this backwards. So what I mean is, we start with the nth term, or A plus n minus 1d. So this would be the nth term. Oh, maybe I should, okay, yeah, that's good. And then we can add the n minus 1 term, n minus 1 term. So the n minus 1 term would be A plus n minus 1, n minus 2 d. And you notice I'm trying to, here. And then the third term would be A plus n minus 3 d. Oh, I've been forgetting parentheses. Whoops. And so forth until we get to A. And so the reason why I wrote this backwards is because we are going to be adding these two series together. So S is equal to this, S is also equal to this. Oh, this is the first term. So how do we add these two things together? Okay, well first we're going to be adding, maybe I should draw a border. we are going to be adding a with this part here. So we're going to be adding a to the nth term, the first term to the nth term, and that is equal, well, 2s, because we're adding this part together. 2s is equal to, well, if we add it, we get 2a plus n minus 1d. So that's our first portion. And then we're going to be adding this term with this term here. And what we get is 2a plus n minus 1d. And that makes sense, right? So a plus a is 2a. D plus n minus 2d is equal to n minus 1d. So there's an additional d in there. And then we can add this portion, and we will get 2a plus n minus 1d. Alright, so you should be noticing a trend by now. Every time we add these two numbers together, we get this same pattern. 2a plus n minus 1d. The sum of n and negative 1d. Right. And this is going to continue on until we reach this term, the last terms for both of these series. And this is also going to be 2a plus n minus 1d. So the question is, how many of these are there? Well, in this series, there are n terms, right? And in this series, we also have n terms. So if we add some of these terms together, we will have n of these repeating blocks in this equation. So 2s is equal to n times 2a plus n minus 1d, or it's equal to s. S is equal to n divided by 2 times 2a plus n minus 1d. And this is, I think this is a pretty complicated formula. So if you ever forget this one, you should just remember how we solved for this, because I find that usually remembering proofs is a lot easier than remembering the actual formula. This is good to keep in mind for the following problems that we're going to be doing, including problem 1. So we wanted to solve problem 1, and we do want to solve problem 1. We know that s is equal to, how many terms do we have? 20 terms for the 20 days, divided by 2, times 2 times a is 10 because that's the first term, plus n minus 1, which is 20 minus 1, d is equal to 3. Now we just need to solve this. Well, that's equal to 10 times, 2 times 10 is 20, plus, substitute this for 3, plus 19 times 3. And that's equal to 10 times 20 plus 3个也乘以 57 equal to 10 times 77, or 770. So all we had to do to solve this problem actually was to substitute our numbers into this equation over here. We need to substitute for n, a, and d. Those were the only 3 factors that we needed to know in order to find the series. And this is definitely a lot easier than the pyramid that I was just drawing, wasn't it? Because for the pyramid, you have to add everything up, add up how many times the 3 appears, add up all the 10s. I mean, knowing this formula is not an excuse for not knowing the proof for the formula, because you should still know how we got here. But I'm just saying, it's a good shortcut for these kinds of problems. Alright, so we did problem 1 and 2. Let's go on to problem 3. And problem 3 is really where this formula right over here is really effective. So I'm going to rewrite the formula up here as a reminder. N over 2 times 2a plus n minus 1. Alright, problem 3. If the sum of the first 10 terms of an arithmetic progression is 4 times the sum of the first 5 terms, find the ratio of the first term to the common difference. Alright, this it sounds really complicated, doesn't it? But if we remember this, it's actually not too bad. So we want to find the first 10 terms of a certain arithmetic progression, and we don't know what kind of arithmetic progression that is, but all we know is that the sum of the first 10 terms is 4 times the sum of the first 5 terms. So the first 10 terms will be represented in this way. 10 divided by 2 times 2a plus 10 minus 1 times b. And that is equal to 4 times the sum of the first 5 terms, which is 5 divided by 2, 2a plus 5 minus 1. Alright, and we have to remember what we're trying to find. We're trying to find the ratio of the first term to the common difference. So a divided by d. Alright, so let's just simplify this. 10 divided by 2 is 5. 10 minus 1 is 9. 5 divided by 2 is just 5 divided by 2. 5 minus 1 is 4. We can simplify this over here. 2, 1. So now we just have 2 times 5, which is 10. And then let's multiply this out. Let's just make this 9d and 4d. So 9d, 4d. 5 times 2 is 10a plus 5 times 9 is 45d. That's equal to 20a plus 40d. Alright, so let's subtract 10a from both sides. We get 10a. Let's subtract 40d from both sides. We get 5d. So 5d is equal to 10a. And remember, we want this to be a ratio. And we can also put ratios in fraction form, like a divided by d. But we can also write divided by 5 on both sides. D is equal to 2a, or a divided by 2a is equal to 1/2. Yeah, that's the ratio of the first term to the common difference, 1/2. Alright, problem 4. What is the 6th term of the arithmetic sequence whose 31st and 73rd terms are 18 and 46 respectively? Okay. Oh shoot, I accidentally erased the formula again. Oh well, that's okay, we don't need it. Okay, well, the 31st term is 18, which means that a plus 30 times the common difference is equal to 18. And the 73rd term is 46, which means a plus 72 times d is equal to 46. And if you don't understand why I have this set up like this, think back to our formula and how we got certain numbers. Think back to the pyramid, actually. So when we wanted the 20th term, we had the original 10, but we jumped by 3 19 times. So the 20th term was 10 plus 3 times 19. And so this here, this is the 31st term, but it's equal to a plus 30d, and that's equal to 18. So now that we have the system of equation, we can figure out what d is. If we subtract upwards, we get 42d is equal to 46 minus 18, 46 minus 10 十六3 28, or d is equal to 28 divided by 42. And we can probably simplify this. Let's start by dividing by, let's start by dividing by 2. 1, 4, 2, 1, 3, 4, 3, 4. I think it's the farthest we can go. Oh, we can divide by 7 again too. So 14 divided by 7 is equal to 2. 21 divided by 7 is equal to 3, 2/3. So d is equal to 2/3. And then we can figure out what a is by plugging 2/3 back into the equation. So a plus 30 times 2/3 is equal to 18, or a plus, well, 10, 20 is equal to 18. So we get that a is equal to -2, and d is equal to 2/3. So now that we have this information, back to the original problem, what is the 6th term of this arithmetic sequence? Well, the 6th term will be -2 plus 5 times 2/3. And that's equal to -2 plus 10/3. And, okay. Well, -2 is equal to -6 divided by 3. That's equal to 4/3. I think. Yeah, I'm pretty sure I'm correct. Yeah, it's equal to 4/3. Alright, problem 5. Insert 3 arithmetic means between 3 and 4. Okay, let's go into what an arithmetic mean means. Man, these words are kind of tricky. Well, let's first think about what two numbers next to each other in an arithmetic sequence looks like, using just variables, of course. So our first number would be a plus n minus 1d. So this is a certain term in our arithmetic sequence. But the term after it would be a plus n times d, because we're adding an additional d to get to the next term. So this is one of the terms. And then the term before it, in this way, is equal to a plus n minus 2d. That's another one of the terms. That's a term that came before it because we're subtracting a d. So now that we have this, here's an interesting thing to consider. When you add these two, this term, here I'll just name them term 1, term 2, term 3. When you add term 1 and term 3, you get 2 times term 2. So alright, let's just add term 1 and term 3. A plus a is equal to 2a, n minus 2d plus nd is equal to 2n minus 2d. And I'm claiming that that's equal to 2 times a plus n minus 1d. Well, if you multiply it out, you'll see that's true. So 2 times a is 2a plus 2 times n minus 1d. That's equal to 2n minus 2d. These two are equal. So what that means is that when we talk about arithmetic means, it means that the middle term between two terms is the mean of these two terms. So you have problems where they ask insert 3 arithmetic means between 3 and 4, and what they want you to have is a sequence like 3, x, y, z that represents those 3 arithmetic means, and 4. And they want you to find a combination of x, y, and z that makes this an arithmetic sequence. Okay, well, how do we do that? Well, we know that we first start with 3, and x has to be equal to 3 plus a certain difference. And then y is equal to 3 plus 2d. And then z is equal to 3 plus 3d. And then we have 4. But we know what 4 is equal to. 4 is equal to 3 plus 4d. So by knowing that, we can figure out what d is. If 4 is equal to 3 plus 4d, 1 is equal to 4d, and d is equal to 1/4. So if we know that d is equal to 1/4, we can figure out what x, y, and z equal. X is equal to 3 plus 1/4, and that is equal to 13/4. Y is equal to, well, y is actually equal to x. Oh, yeah, okay. Y is equal to 3 plus 2d. 3 plus 1/2. And that's equal to 7/2. Z is equal to 3 plus 3d, so 3 plus 3 times 1/4, 3/4. And that's equal to, this will be 15/4. And what you notice is that all of these in this sequence, all these numbers, if I erase all of this, if I substitute what we figured out what x, y, and z is, if I substitute this back into the sequence, we get 13/4, 7/2, and 15/4. You notice that it keeps the property of being an arithmetic sequence. So 3 plus 1/4 is equal to 13/4. 13/4 plus 1/4 is equal to 14/4, which is equal to 7/2. So this keeps the same pattern. And 7/2 plus 1/4 is equal to 14/4 plus 1/4, which is equal to 15/4. And then 15/4 plus 1/4 is 4. So this is how we just confirmed that what we did here was correct. Alright, thank you guys for watching this video on arithmetic sequences. The next one will be on geometric sequences.